So let's start our astronomy class with obviously a picture of galaxies, in case you didn't realize this is what it is. For example, this is something that someone would easily recognize as a galaxy. Here's another one, also kind of looking like a galaxy, but surprise, surprise, even this is a galaxy, even this is a galaxy. Actually, every tiny little dot here is a galaxy, with only two exceptions, and those are these things, which, well, I have some experience with these things. These are stars. These are foreground stars. They're not as far away as the galaxies, which is every single luminous thing in this image, every little point. Okay, and I know that because of these spikes. Those are due to the diffraction process that happens when you have a point source and then meets the structure of the telescope. That's when it happens. So it's a really, really big difference in distance. Like these stars are really close, much closer to us. Not very close, obviously. Nothing is close. It's not. Space is not called space for nothing. It's a lot of emptiness out there. But the stars are much closer to us than the galaxies, or every single luminous dot in this image. This image is actually a very famous image for any astronomer you might think about talking about. This is called the Hubble Deep Field. It's obtained with the Hubble Space Telescope, and it is an image of a tiny portion of the sky. It's as tiny as about a third the size of the moon. So that's tiny. And before Hubble Space Telescope looked into that tiny portion, we didn't have any evidence of anything being there. It was simply dark. But after Hubble Space Telescope peered into that tiny space, obtained this image where we have been able to identify about 3,000 galaxies. So that's pretty cool, I would say. I hope you're impressed as well. And I wanted to start with this image to basically pose the first question that we want to address, which is, what's our place in this universe? Basically, how do we relate to a picture like this? How do we relate to galaxies or stars and all the other things that we're basically going to learn about in this class? So I'm going to exemplify for you one of the types of the questions that are going to show up in the homework or exams. So for example, we have here a bunch of options of a sequence of different cosmic entities, like you being one of them, or the planet you live on, or things that are called solar system or local group, local supercluster, or the Milky Way Galaxy, or the universe. And so they're in a different order, and you would have to read them and identify what is your correct cosmic address. Okay, so we're not going to do it now. You can read it, and I want to help you identify the correct answers. Let's do that. And the answer is actually in this really beautiful diagram, which shows us, kind of summarizes, the evidence that we have so far that our place in the universe looks something like this. We live on a planet. That's this one, Earth, the big or small blue dot, as some also call it. My students, you, must be somewhere in this region on this planet, right? Okay, so what I wanted to point out is that you live on a planet. Planet is the Earth. The Earth is tiny. This one of 8 planets, right, that orbit a star, which is the Sun. And the other planets, let's identify them here. So the closest one, Mercury. You probably recall the next one is Venus. Again, this is Earth, our favorite. And then you have Mars. And then you travel some more towards the outskirts of the solar system. This is what we have here, a star which is orbited by planets, and then you find Jupiter, the king of the planets in the solar system, and then a beautiful one that has awesome rings, Saturn, and then it's Uranus and Neptune, the most far away one. And I kind of wanted to identify all these things for you because we are just not going to talk about these things in this class, because this class is not about the solar system. We're going to move on and talk about other stars, starting with our own, the sun, and then we're going to move on to talk about other stars, and then places in this universe where stars form and evolve and how they evolve, and those places actually turned out to be galaxies, and the one that's closest to us is the one we live in. So all this solar system, this is just one dot, right? So there are hundreds of billions actually of stars like our own in an ensemble of stars that actually make up a galaxy. Okay, so you can identify here a high density of stars in the center. We call that a bulge. It looks like a bulge, and then you can identify some spiral arms, maybe. Yeah, we do have names for them and all that. So that's our own galaxy. We live in it. It's kind of like a pancake or a fried egg, if you want. That's its structure. In case you didn't know, but it's important to realize that, that the universe doesn't stop there. So yeah, we're a tiny speck inside one galaxy, but hey, guess what? Our Milky Way is just one of a group of galaxies, and in this local group of galaxies, there's another one you probably have seen as screensavers on the Mac computers a few years ago. This is Andromeda, which looks a lot like Milky Way. It's often referred to as the sister of Milky Way, and there are also some other smaller galaxies. These are all galaxies. They're dwarf galaxies, and together they form this local group of galaxies. And guess what? There are many groups of galaxies like this. So this is one, the local group, and then, for example, there's another one. The galaxies kind of like to group together, kind of like people do in cities. And when some cities are grouped together, you get a twin city group or something. In this case, we call it a local supercluster. And then we move on, and guess what? The universe it seems to be, based on all the measurements we've done so far, right? So this is just one local supercluster, and there are obviously many. There's a whole web-like structure of clusters of galaxies. So with all this information, right, I think you're now ready to identify the correct answer to our cosmic address, which is going to be you, who's living on the Earth. Earth is one of the planets in the solar system, which is the star that is surrounded by the planets. This solar system lives in a galaxy that is the Milky Way Galaxy, which is one of the galaxies in the local group, and the local group of the galaxies is one of the groups in the local supercluster, which is one of the clusters that make up the universe. Right. Guess what? We have another question that's related already to the material we discussed so far. And the question is, where is our solar system located? Within the Milky Way Galaxy. So if you remember, our galaxy kind of looked like this. It had a bulge, a high density of stars, and then some spiral arms, right? So it's kind of like this, right? That would be the plane of the galaxy, okay? So some options here are, where is it? Is it near the very center of the galaxy? Is it roughly halfway, right, between the center and the edge? So the edge, right, would be here. Or is it in a halo, right? This is what we call the halo. There are some actually stars that live in a spherical-like structure that surrounds the galaxy. So this is the halo. Or at the far edge. So it's either in the center, either halfway in between the center of the edge and the edge, or at the edge, or somewhere in the halo. If you look back and you look again at where our solar system is, this is the center and this is the edge. It's halfway in between those two. All right, so the correct answer would be this one, roughly halfway between the center and the edge of the visible disk of the galaxy. All right, so what is the universe then? It's the whole galaxy web, right? A web-like pattern of galaxies. They're filling up this whole space that we have been able to measure so far. As much as we've been able to measure makes up the so-called visible universe. What is beyond that, we have no idea, right? The universe itself, it's possibly an infinite region outside our visible universe, but there's no way we can actually tell what's happening there. And we're going to come back and address these concepts, especially in the very last day, the very last chapter, but even before that a little bit. Another question, which you probably have thought of, okay, is how is it that we came to be in this universe full of stars and galaxies and clusters of galaxies and superclusters? At the very beginning, we have evidence that the galaxies, which you see here, right, the clusters of galaxies, this is one galaxy, this is galaxy, very much looking like the Milky Way. But all these groups of galaxies, right, they were clumped together in time, and we believe that all this distribution of the galaxy was smaller and smaller and smaller because the galaxies keep kind of moving away from each other, and so all this space is becoming larger and larger and larger. So it must have come from basically one single point. We call that the Big Bang. You can call it the beginning of everything. You can use whatever label you feel like for that. At the very beginning, there was only hydrogen and helium, and the matter was very homogeneous, as you can see here in, kind of a much smaller version of a portion of the universe that is illustrated here. It became larger and larger, and the matter clumped and formed the galaxies. It turns out that as soon as the things started to clump, the gravity was strong enough, and especially inside galaxies, the gravity was strong enough to help the gas collapse. So gas collapses under gravity and forms stars. And the stars live. They basically exist as stars, and as we will see, a living star converts hydrogen into helium and then helium into carbon, and so carbon and nitrogen, oxygen are formed while a star lives, and after all the hydrogen is depleted, a star dies and actually explodes. And what happens during the explosion, and these explosions are different for different types of stars of different masses and we're going to have the chance to learn about these things. They return back into that space or matter in between stars. They return back that material, all that newly formed carbon and nitrogen and oxygen and iron, all that, those heavier elements that are very useful for things like forming planets and people. And this is how we came to be. And in case this rings a bell, right, I'm sure maybe your parents or other dear people close to you might have told you that you are stellar material. Well, guess what? You just realized today that if it were not for the stars to be born, live, and then die and return that enriched material, and then for having that cycle continue like this for quite a few times to obtain enough of these things we are made of, we and the planet, we wouldn't be here at all. So yeah, stellar material, that's exactly what you are.